Lesson 4, else and elif, and then snakes and ladders to finish it up. You've got 4 stages on this one. This one, we are learning about the else clause. A lot of you from your conversation with the computer, well, I'm expecting that some people have already asked and already would have. You might have thought, well, if I didn't do swimming or I didn't do something like that, or if the user types something else, how do I handle what I'm going to do? Because at the moment, in the previous lesson, all we were able to do was say, if I liked swimming, or if they said swimming, say I like swimming too. So you can't say if they put, I don't know, tennis, you can't say otherwise. So this is a really powerful, useful statement to use in your program. So in this little example, we've got the if statement just like before. Let's go through what we've got. We've got enter password in an input clause. So that's going to make enter password appear on screen, which it does, enter password. Then you're going to see your square colon. You see the square cursor, and you're going to see the square cursor because of this input. What's it waiting to do? It's waiting for me to type a password, and then it's going to assign it to the variable p. If you look ahead, you'll notice that it says if p contains, or if p contains the string capital P A55W0RD colon. That's not part of it, so it's looking for the string to check whether they've typed that. And if that is what they typed, it'll say password correct. Otherwise, it'll say wrong password. So you can try that out. PA55W0RD. And you can see it's going to say password correct. If I run it again and type any old nonsense, you can see that's the wrong password. So the reason that we got the wrong password bit is because of this. And that, it means if this is not true, if this doesn't happen to be the case, it'll always do whatever in the else clause. Little demo of that, in your case, write some code to display that is 10 if the user enters the number 10, and that is not 10 if the user enters any other number. So let's try it out. We can come up with a variable. At the moment, we've got enter a 4-year digit in the form n equals 1615, the founding year of the purse. So if they put 1615, let's try another one. So write some code to display that is 10 if the user enters the number 10. So we need a variable name for storing 10. We could use any variable we like, but I'm going to use, how about t for 10? And we'll go t equals input. Please type a number. We like to put a little colon and a space. The reason we do that is because it's really nice and easy when they're down here in the terminal, so they can read where their cursor goes, and it's just easier, and you'll see how that looks in the terminal when we run it. We need an if statement, if, and now we need the variable, which in this case was t, and it's not a single equals. If t contains, or t equals, and we want to say, not 10 like so, we want to say if it equals the string 10. And the reason it's going to be the string 10 is because all input always is a string by default. Later in year 8, or maybe even, I think when we revisit Python later, you'll be learning about how to change strings to integers. But for the moment, input from the user is always a string. We put a colon, we press enter, and you can see that the code is already tabbed in, which is what we want. And we want it to say, that is 10. So I'm just going to copy that as 10. Copy. And we print it. Print. Speech mark. Paste. That is 10. And then we use the else clause. Else. Print. That is not 10. Easy peasy. Run. Enter a year in the 4-digit on 1615. The founding year of the person. Please type in a number. Let's use 10. And that is 10. If I did it the other way around, it would also work the other one. How about if we want to say otherwise if? This one's a little bit more powerful again, and we can have as many of these. So the way this reads is input the color of the rainbow. If what the user types is this string red, roses are also red. Elif means otherwise if. If this is not true, it'll do this. Otherwise if Z contains orange. That's my favorite flavor of Smarties. Otherwise if Z equals yellow, sunflowers are that color. Otherwise, if none of those have happened to be true, in other words, they didn't type red, they didn't type orange, and they didn't type yellow, anything else, do this, which is I don't know that color. You can actually have as many elifs as you like. So if I copy this one and paste it in, you can choose a different color. So you can type otherwise if Z contains, or pink, blue, doesn't really matter which color you use. and then come up with some quirky thing for it to say if they're blue. I don't know. Let's think. Roses are also red. That's my favorite color. Smart sunflowers are that color. I don't know. The sea is blue. Yes, very original. And you can come up with some more LF clauses and then try that one out. And finally, we get to have a little game. Now we should have all the tools we need in our arsenal to make a little game of snakes and ladders. And for this, we're going to say, well, the program as it currently lies, if we run it, if we play the game, what square am I on? Well, we start the game on square 1. So I guess I'm on square 1. What did I roll? I rolled a 3. You're on square 4. That's what's currently happening in the game. And every time we press play, it's going to have to rerun again. Sadly, we can't get it to run automatically. We haven't learned about looping, but for this, we can do a manual game where we always we can keep the game going, and you can work this out on a snakes and ladders board. If square is 25, and so on. So let's get a snakes and ladders board. Let's have a little look. How about, I don't know, are all snakes and ladders boards the same? Let's have a think. Well, there's my snakes and ladders board. We'll use that one for this one. And you can see I got onto 4, and that would have taken me on a ladder to square 14. So let's go back to my project. And we can add that in. So it's going to be very similar to if LF square is 3, go up the ladder to 14. So I'll copy that. I mean, you can change this to the snakes and ladders board. Otherwise, if square is 3, I mean, this one was, I got a 4. So, I mean, that would have taken me up to square 14. So you're going to be putting in a lot of LF clauses here for the snakes that take you down and the ladders that take you up. So that one would have been, otherwise, if square is 4, go up the ladder to 14. Well, this person must have been using a different snakes and ladders board to me, so it doesn't really matter. Is 25 the win on my board? No, on my board the win is 100. So this could be a very, very large, very, very large program. You'll notice a slight difference in this one. We said in stage 3 that all user input was a string. Or did we say that in stage 2? I can't remember. Yes, it was this one. We said, did t contain the variable or the string 10? You'll notice slightly differently here. We're using if square is equal to the integer 100. And the reason we're doing that is because of this little section of code as well. We've got an extra close bracket, an extra open bracket, and the three letters int. Int is short for integer. And what it's doing, the term of what we're doing here is taking whatever the person typed for what square you are on, and then we're writing int open bracket, and then we're closing the bracket again, so we end up with 2. What that means is take whatever the person types and cast it to an integer data type. Of course, the implication is that they did type an integer. It breaks if they don't type an integer. And again, in the future, you'll understand how to deal with that. But for the moment, all we're doing in this program is adding in, for your massive snakes and ladders board, a giant if, elif, and so on. So, I mean, let's do another one. So if I was on 1, I don't know if we start on 1, I would have got to 38. I'm assuming on this board we start on 0, and if we roll a 1, we get to 38. So we can do that. So I don't know. That was my first one. I just added in. So let's add in another one. I can put as many lines in here. It doesn't really matter. I'll paste another one in. If we end up on square 1, where did I go to? I would have gone up my ladder to 38. So you get the idea there. And you just keep going and keep adding in extra little bits. If anyone gets that finished for a giant, I don't know, 100-point snakes and ladders board, maybe I can show you how to actually make it loop. But that's not what this is actually about, a looping lesson. The reason we had to make that integer data type was we were going to try out some calculation, and you can't carry out your calculation on a string. It wouldn't work. So you couldn't add the throw that the person did to the square they were on if you had used strings.